Good morning, dear students. Today we'll start a new lesson which is equivalent fractions. The last lesson we took the meaning of fractions, reading and writing it. Today we are going to take the equivalent fractions, which are two or more fractions that mean the same thing, the same amount, but have different numerators and denominators. Let's see. Here I have 1/2. 1/2 is equivalent to 2/4. When I divide this half into two equal parts, so it gives me 2/4. They are having the same amount, the same value, the same shaded part, but they are different in numerators and denominators. Is equivalent to 3/6. They are having the same amount, the same value, the same shaded part, but they are different in numerators and denominators. So 1/2 is equivalent to 2/4 is equivalent to 3/6. The numerators on top are different. The denominators on bottom are different. But the three fractions all take up the same amount of space and have the same value. More equivalent fractions. Here I have 1/2. 1/2 is equivalent to 4/8. When I have this half, I divide it into four equal parts. They are having the same amount, but they are different in numerator and denominator. Is equivalent to 5/10. This one whole is equal to halves, is equal 4/4, is equal to 8/8. This half is equal to 2/4 and equal to 4/8. This quarter equal to 2/8, and so on. Equivalent fractions can be found by using a fraction wall like this. Those two circles are divided into different number of parts. The first one is divided into 3 equal parts, and the second one is divided into 12 equal parts. When I see 3 and 12, what is the relation between 3 and 12? 3 times 4 equals 12. So I can say 2/3 times 4/4 equals 12. They are having the same amount, the same shaded part, the same value, but they are different in numerator and denominator. So I can say that 2/3 is the same as or equivalent to 8/12. Remark: a fraction can be built up to an equivalent form by multiplying both the numerator and denominator by the same number. 1/3. When I multiply up and down by the same number, for example 2, it will be 2/6. So 1/3 is equal to 2/6. 2/3. When I multiply up and down by 3, it will be 6/9. So 2/3 is equal to 6/9. They are having the same amount, the same value, but they are different in numerator and denominator. 2/5. When I multiply up and down by 7, it will be 14/35. They are having the same amount, the same value, but they are different in numerator and denominator. Sometimes we'll be asked to find the missing denominator or numerator in a pair of equivalent fraction. Here, 3/4 equals dots over 12. What is the relation between 4 and 12? 4 times what equals 12? 4 times 3. I have to multiply up and down by the same number. So 3 times 3 equals 9. Another one, 5/7 equals 2 dots over 35. What is the relation between 7 and 35? 7 times 5, it will be 35. So 5 times 5, it will be 25. 3 over 5 equals 12 over dots. What is the relation between 3 and 12? When I multiply 3 by 4, it will be 12. So I multiply 5 by 4, it will be 20. 5 over 9 equals 45 over dots. What is the relation between 5 and 45? 5 times 9, it will be 45. So 9 times 9, it will be 81. Another remark. A fraction can be built up to an equivalent form by dividing both the numerator and denominator by the same number. 18 over 24. 18 and 24, I can divide it by 2. It will be 9 over 12. 9 over 12, 9 and 12, both of them are found in table 3. So I can divide them again by 3. It will be 3 over 4. I can't find 3 and 4 in any table, so no more division. I can say 18 over 24 divided by 6. Why? Because 18 and 24, both of them are found in table 6. Here I have 2 and 3. What is the relation between 2 and 3 and 6? 2 times 3, it will be 6. So 18 divided by 4, 18 over 4 divided by 6, it will be 3 over 4. Another one, 27 over 63. 27 and 63, I can divide it by 3. 27 divided by 3, it will be 9, and 63 divided by 3, it will be 21. 9 and 21, both of them are in table 3, and I can divide them again by 3. 9 over 21 divided by 3, it will be 3 over 7. I can say that 27 over 63 divided by 9. Why? Because 27 and 63, both of them are in table 9. And what is the relation here? 3 and 3. 3 times 3, it will be 9. It will be 3 over 7. Sometimes we'll be asked to find the missing denominator or numerator in a pair of equivalent fractions. 16 over 24 equals dot over 6. What is the relation between 24 and 6? 24 divided by 4, it will be 6. So 16 divided by 4, it will be 4. 4 and 6, both of them are found in table 2. I can divide them again by 2. So 6 divided by 2 will be 3. 4 divided by 2, it will be 2. And I can say that 16 over 24. Who can remember 4 and 2? Here I multiplied them. 4 times 2, it will be 8. I can divide them by 8. Why? Because 16 and 24, both of them are found in table 8. 24 divided by 8 equals 3, and 18 divided by 8, it will be 2. Another one, 18 over 63 equals 6 over dots. What is the relation between 18 and 6? 18 divided by 3, it will be 6. So 63 divided by 3, it will be 21. What is the relation between 6 and 21? Both of them are found in table 3. So I'll divide them again by 3. It will be 2 over 7. And I can say 18 over 63 divided by, here I have 3 and 3. So 3 times 3, it will be 9. Why? Because 18 and 63, both of them are found in table 9. So 18 divided by 9 equals 2 and 63 divided by 9 equals 7. Here I have a remark. Number 1. If the top and bottom numbers are both even, use 2 over 2. Number 2. If the two parts of the fraction, up and down, numerator and numerator, end in 0 or 5, you can divide by 5 over 5. 45 over 70 equals 45 divided by 5 over 70 divided by 5, it will be 9 over 14. Number 3. If both numbers end in zeros, you can cancel the zeros in pairs, one from the bottom and one from the top. This is the same as dividing them by 10 over 10 for each cancel pair. For 1000 over 50,000, I will cancel all the zeros. It will be 4 over 50. 4 over 50 divided by 2, it will be 2 over 25. Thank you.